So while riding in the elevator descending at a constant speed of 3.6 meters per second, you accidentally drop a book from under your arm. How long does it take for the book to reach the elevator floor 1 meter below your arm? So again, this is a same place, same time problem. So same X, and by X I mean position, like X marks the spot, and same T. So same place, same time. Now here we have an elevator and we have a book. And the elevator, stick man of science, and the book under the arm, do you love that little book right there? They're all moving down at negative 3.6 meters per second. The whole thing is moving at negative 3.6 meters per second. So the initial speed of your elevator is negative 3.6 meters per second. And the initial speed of your book, even though it's dropped, is moving at negative 3.6 meters per second. So that means that the acceleration of our elevator is 0, but the acceleration of our book is the acceleration due to gravity because it's in free fall. Now for the elevator, we're going to have delta y equals v naught t plus 1/2 a t squared. Now I used the delta y notation because the elevator is going up and down, but I didn't use negative 1/2 gt squared because the elevator is not in free fall. Okay, so delta y means final minus initial. And our acceleration is 0. So the final position of the elevator, y, minus, I'm going to let the elevator start at 0. And the initial speed would be negative 3.6 t. Now for the free fall of the book, delta y equals v naught t minus 1/2 gt squared because he's in free fall. So final minus initial. This is 0, not 0. That is negative 3.6 t minus 1/2 10 t squared. Now here, the initial position of the book, it's above the floor by 1 meter, so y naught is 1. Now I can solve these two equations. So y is equal to negative 3.6 t. So I'm going to take this guy right here, and I'm going to substitute it in for y right there. So I'll have negative 3.6 t minus 1 equals negative 3.6 t minus 5t squared. Now this is where you can see that the speed of the elevator and the speed of the book are a wash because they are moving at the same speed. But you can also see that if I had thrown the book down with a bigger initial velocity, this is where it would also matter, that they were not the same speed. Okay? So this winds up being really nice there because I don't have to deal with a quadratic, because if I add negative 3.6 t to both sides, I get negative 1 is equal to negative 5 t squared. So t is equal to the square root of 1/5, which I think is 0.447, I think. Alright, the next part asks for what's the book speed relative to you when it hits the floor. So relative to you, the initial velocity of the book is 0 because you were holding it and it wasn't moving relative to you. And so if you're looking for the velocity at the end relative to you, so then the initial velocity is 0, it's in free fall, and the final velocity relative to you would be negative 4.47 meters per second. And there you go.